Hey everybody, Trey here. Welcome back to another video. We're now a few days removed from our moderate risk severe weather event across the southeast back on Tuesday, November 29th. And it was a very interesting event to watch unfold. The expectation was for an outbreak of long track strong to violent tornadoes across the region, and that didn't really materialize as expected. Now, this was far from a bust of an event. There were over 200 severe weather reports in total, 61 of which were tornado reports. Now, to clarify, that doesn't mean there were 61 individual tornadoes, just 61 reports of tornadoes, but there were at least 30 or so tornadoes, individual tornadoes with this event. So, including one that did that caused some fatalities over here in south central Alabama in the overnight hours. So, there were a lot of storms that had meaningful impacts to people's lives and property. So, by far, this was not a bust of an event. However, forecasts were for an outbreak of long track tornadoes, and that didn't really materialize. And so I thought this would be a good opportunity to kind of dive into the data from that day and take a look at maybe why the long track nature of the tornadoes did not quite materialize as expected, especially with the daytime portion of the event. So once again, this was not a bust of an event. There were several tornadoes here. Some of the notable tornadoes here. This was one near Bassfield, Mississippi. Great drone shots here of this tornado that was a precursor to a larger tornado near Bassfield as the sun was setting. Incredible shot here of a tornado in the Mississippi River Delta near Thomastown, Louisiana, which is along the Mississippi-Louisiana border there in the Delta. Incredible shot there. And then this one, just back to the west-southwest in Caldwell Parish, Louisiana, back in the trees. You can see there a large tornado doing some damage there. This one actually was rated EF3 and did some ground scouring along its path there. And then one more notable one here from the kind of Mississippi-Alabama state line there in southwest Alabama. Another EF3 tornado did a 19-mile path near the town of Fruitdale, Alabama. So, very impactful event. Definitely not a bust, but as far as the long track nature of the tornadoes goes, underperformed a little bit from reality. So, let's go ahead and dive in here. We're going to start with a brief synopsis of the meteorology of the event. This is just going to be a brief synopsis, as I said. If you want a more in-depth look at the meteorology of this event, go ahead and check out my forecast discussion video from the morning of November 29th. I'll put the link to that in the description below. I really went into detail with my thoughts on the overall pattern there. This is just going to be kind of a brief summary of the overall meteorology of the event before we get into the potential failure modes as far as the long track nature of the tornadoes goes. So we'll start here at 500 millibars, as we always do. And you can see at the start of the period, very broad troughing across the United States here. You can see that trough stretches all the way from the Pacific Northwest all the way over to the Great Lakes region. So a very large trough here across the United States. And as we went into the afternoon hours, you can see kind of some semblance of that dual jet structure that we talked about in our forecast video. You can see one kind of belt of winds kind of along this axis here, just to the south of the main axis, associated with the trough, rounding the base of that trough there. So this was the subtropical jet, kind of merging with the polar jet, if you will. And this is kind of a classic look with some tornado outbreaks of the past, including December 10th, 2021, where you have this kind of dual jet structure here. But this southern band of enhanced flow here was across the risk area here, especially northern portions of the risk area. And again, we talked about how this kind of general southwest flow tends to allow the forcing to remain subtle over the region. You're just looking for little confluence bands in the low levels, very small embedded shortwaves there within the broader southwest flow that help fire very discrete storms. And we'll talk about how that didn't really materialize in a second here, but overall the thought was for some widespread scattered development here across the risk area, given the kind of subtle forcing aloft. We'll go down to 850 millibars here, take a look at our low-level jet. You can see we start the day with a pretty strong low-level jet across the region here out of the south-southwest with a kind of broad fetch of low-level moisture there. So strong low-level jet stayed in place throughout the day and then increased into the overnight hours across Mississippi and Alabama from about 40 to 45 knots to 50 plus knots there across the region. So strong low-level jet, helping to both enlarge the low-level wind shear and really pump that juicy low-level air into the region throughout the day. Surface pattern here, surface low to start the day across northeast Kansas. That was slated to move off toward the northeast throughout the period, and that's exactly what it did, keeping a very broad fetch of southerly flow here with a juicy air mass in the low levels there. So a very broad warm sector was in place throughout the day. We take a look at our surface map here. We started the day with the moisture kind of confined to far southern Mississippi and Louisiana there. It was yet to advect into the region, but given that very strong mass response on along that strong low-level jet at 850 millibars and that strong surface low off to the northeast, really helping to back the winds out of the south here across the warm sector. That would really help pull that moisture northward throughout the day. And we had a very broad swath of mid to upper 60s dew points here, stretching all the way into East Texas here as we went into the daytime hours, and that would continue to get pulled northward with time. So very broad warm sector, and that was one of the kind of eye-opening factors with this event, was just how broad the warm sector was. You had a very strongly sheared profile over strong kinematic and thermodynamic profile across a very broad region. So there was a very large expanse of territory where favorable conditions for tornadic supercells existed. So this was the sounding here. Started off at 12Z here at Jackson. This was the observed sounding here. You can see very strong warm advection was underway. Strong curvature in the low levels there, strong veering of the winds in the low levels, but we were definitely north of that warm front in the morning hours. But by 18Z, we were at Jackson, well within the warm sector by this point. On the channel here, I put out a post saying this was about as good as it gets, and that it's really pretty favorable conditions here. Started to overspread the region early in the late in the morning, early in the afternoon here. You can see fully destabilized here for the most part here at Jackson, with a wind profile very favorable for tornadic supercells here. Large curvature in that low-level hodograph with very long hodographs favorable for right-moving supercells to take advantage of this storm relative helicity. Did note a little bit of a sort of saturated layer there in the low levels that was leading to some fairly weaker lapse rates in the low levels. Again, that lapse rate is that change in temperature with height in a given layer. And the higher that number is, the steeper that lapse rate is, the more efficiently those parcels, those air parcels, can rise into the vertical and accelerate and become more sort of robust updrafts. And that was a little bit lacking here in the low levels. And if you recall in my forecast discussions leading up to this event, my main concern with the event as far as a failure mode was these weak low-level lapse rates. And we'll talk about that in a second, whether that played a role or not. But this was something that was catching my eye here. But for the most part, this profile was very, very favorable for tornadic supercells across the warm sector as the afternoon progressed. So we'll take a look at our radar here. We'll take a look at the Jackson radar, kind of a broad view here in the morning. We had our first batch of storms fire early in the morning here, about 8 or 9 a.m. in far southeast Arkansas, far northwest Mississippi. Those quickly moved off toward the northeast. Again, these were well to the north of the warm front, so they were very, very elevated in nature. As we continued in time, those became a little bit more numerous and moved off toward the east. Maybe some sporadic large hail reports with these storms as they were elevated north of the warm front. But then we started to watch these areas back out to the south and southwest, back here across Louisiana. So just some showery activity started to develop across the border into Louisiana, including the first tornado warning of the day that occurred well back here in Louisiana, closer to the Fort Polk radar site. But we were watching, in particular, these storms here moving out of northeast Louisiana into central Mississippi, right into the heart of that moderate risk area. You can see a preponderance of just showery activity across the region really start to take shape and became more numerous with time. You can see that we didn't really have that very sort of sporadic, discrete development as we had expected. Storms were fairly discrete still, even though they were kind of clustered somewhat. You still had discrete sort of updrafts in here, but there were a lot of storms overall that fired in the open warm sector. And this, in hindsight, may have been a hindering factor to the overall severity of the event and the long track nature of these tornadoes. Some of the more favorable events, as we've seen, April 27th, December 10th, 2021, had a very sort of discrete storm mode. Storms really didn't cluster like this from the get-go. You had very discrete storms. Now, again, storms remained fairly semi-discrete here, but there were just a lot of storms overall. And I want to turn your attention here to, this is the radar from December 10th, 2021, our quad-state tornadic supercell that produced a couple of long-track violent tornadoes here, including the one that hit Mayfield, Kentucky. That's this storm right in here as it moved out of the Missouri boot heel into far, far northwest Tennessee, southwest Kentucky. But you can see the difference in the radar here. We had a very sort of pockmarked warm sector here, and nothing at all to compete with this storm for those juicy ingredients that were feeding up into it. Nothing out ahead of it. With some storms back here to the west, but those were not impeding the progression of this storm at all. Just a few sort of discrete supercells out here in the open warm sector, as opposed to what we're seeing, what we saw on the November 29th event. Just an overall, large amount of storm coverage. So perhaps these storms to the south were kind of impeding the most favorable ingredients from reaching the northern portion of the outlook area, and these storms generally remain sort of either weakly tornadic or non-tornadic. They would kind of cycle, tighten up for a couple scans, and then kind of weaken over time. And again, we'll talk about that more in depth in a second. But we did have several tornado producers in this event, especially with southern extent here. This kind of cluster coming out of Louisiana would produce some tornadoes. This one to the south of Jackson would produce some tornadoes as it near the Bassfield area with time. And we continued to see these storms kind of fire. Again, you can see a lot of showery activity here. Storms did remain fairly discrete. These were a couple supercells up here near Yazoo City, Mississippi, that tried to tighten up but couldn't really do it. So generally there was a line kind of just north of the Jackson area where storms generally remained fairly non-tornadic. We had one spin up here that produced a debris ball near Columbus, Mississippi, and then one supercell here that produced some damage near the Eupora, Mississippi area. But overall, the storms kind of to the north tended to be either weakly tornadic or non-tornadic, while these storms to the south tended to be a little bit more tornadic, especially after dark, and we'll talk about that in a second as well. So one difference right off the bat was just the overall storm coverage. I think it was a lot greater than what forecasters were expecting, rather than a just kind of pockmarked warm sector given the degree of subtle forcing across the warm sector. That didn't really materialize. We had a lot of storms across the warm sector, even though they remain semi-discrete. That may have been one limiting factor to this event. So now that we've gone over the meteorology of the event, let's dive into some of the possible failure modes with this event. And the first one that we'll talk about is the potential low-level lapse rate issue. If you recall in our forecast discussion videos leading up to the event, my main concern that I thought might temper the overall threat of the outbreak was the fact that the low-level lapse rates were modeled to be very, very weak across the region. Generally, we want to see lapse rates above 6 degrees Celsius per kilometer, and the higher that lapse rate goes, or the steeper that lapse rate is, the, again, more able those near-surface parcels are to accelerate upward in the vertical and become more robust updrafts. And so with low-level lapse rates, you want to see lapse rates definitely above 6 degrees Celsius per kilometer. If you get them in that 7 to 8 kilometer range or greater, that's when you have a very favorable environment to get those parcels accelerating in the vertical. And as you can see here on our SPC Mesoanalysis archive page, these are the 0 to 3 kilometer lapse rates across the region. And you can see we don't really increase a whole lot throughout the day. We kind of have a broad swath of 5.5 to 6.5 across the region here. So low-level lapse rates really did remain fairly weak. Now, what we can do is take a look at some RAP model soundings from some locations within the outbreak area. And we'll take a look at 4 different locations here: Greenwood, Mississippi, Columbus, Mississippi, Jackson, and then down by Hattiesburg and Laurel, which was in the vicinity of that Bassfield tornado that we showed earlier. So we'll start off with our proximity soundings from Greenwood, Mississippi here. This was on the northern kind of fringes of the outbreak area. So you can see here as we start the day, this is at 12Z. pretty much what we were seeing across the region. Low-level inversion because we were well north of that warm front. It was still retreating northward. Strong warm advection ongoing, veering winds in the low levels, helping to really bring that warm front northward fairly efficiently. And by early afternoon, we were well within the warm sector here. You can see just after lunchtime, 73 over 64 at Greenwood with a very fully destabilized profile for the most part there, and a photograph that was very favorable for tornadic supercells, should any right-moving supercells take advantage of that environment. Now, if we look at our low-level lapse rates here, again, this is just after lunchtime, this is about noon, 6.8 degrees Celsius per kilometer was our surface to 3 kilometer lapse rate here. So these RAP soundings were being a little bit generous with the overall low-level lapse rates. You can see here, take a look at this layer near 1 kilometer, still dealing with a little bit of a weakness in the lapse rates right in there. And that kind of remained throughout the afternoon hours. A little bit of convection ongoing here, but you can see that the temperature profile is fairly just vertical in this layer. That means lapse rates were very, very weak in that layer, and by 22Z, lapse rates had decreased to about 6 degrees Celsius per kilometer within this layer. If we go down to the south near, let's take a look at the Jackson sounding. Similar progression down here at Jackson. Low-level lapse rates a little bit stronger down here, though, 7.1 degrees Celsius per kilometer in the low levels here at Jackson by 21Z, about 3 p.m. there. So I don't think low-level lapse rates were that much of an issue. Definitely would like to see them a little bit higher. And if we compare them to past outbreaks, for example, the April 27th, 2011 outbreak here, let me pull up the April 27th soundings here and kind of compare them for you. These were the Birmingham observed soundings from April 27, 2011. And right off the bat, you can see a big difference between our soundings for the Tuesday event and April 27th. Take a look at the low levels there. 0 to 3 kilometer lapse rate of 8.8 degrees Celsius per kilometer. And this was at 18Z, right as storms were starting to initiate. So very, very steep lapse rates in that layer. They decreased somewhat throughout the day as we continued to moisten that low level layer, but still 6.7 degrees Celsius per kilometer, more than adequate for tornadic supercells there. So generally in your stronger, your more notable sort of southeast outbreaks, we do have a little bit stronger low-level lapse rates. But still, these were somewhat adequate. I don't think this was the main hindrance to this event, although we would like to see them a little bit larger for a more substantial tornado threat there. So this ties into what I do think was kind of the major inhibiting factor for at least the daytime portion of the event, and that is the fact that the storms appeared to be slightly elevated in nature. So if we go back to our Jackson RAP soundings here, we go through the day, you can see that we destabilize, but then by 0Z, watch what happens in the low levels. We get this sort of inversion, kind of dual inversions here in the low levels, and that was also apparent on the 12Z, the 0Z Jackson sounding. This is the observed sounding from Jackson at 0Z. And notice this little inversion sneaks its way in here just above the surface by 0Z at Jackson. You can see that little kink in the temperature contour there, a little bit of drier air there. So that may have allowed storms to remain just slightly elevated above the surface. And that would explain why the storms tended to be a little bit more hail producers rather than tornado producers. I remember being out chasing, looking at the radar, and noticing how much these storms just kind of looked like hailers, not really tornado producers. They would have large hail cores. Here's an example of that Vaden's of this supercell near Vaden, Mississippi. I'll show some hail from that in a second. But it just has a very strong reflectivity core, kind of that dog-legging appearance there. Here's one from northwest Alabama as well, strong core, kind of that dog-leggy appearance. So these look more so like hailers rather than tornado producers on radar, just kind of anecdotally. We saw several reports of large hail here. This was from the Vaden, Mississippi area along the I-55 corridor well north of Jackson. This is some pretty large hail, especially for southeast standards. And that doesn't really go with the fact that we had very strong low-level shear to deal with, or to work with. We've seen some recent research from people like Cameron Nixon and John Allen that shows that when you have strong low-level shear, the production of large hail is often inhibited, and you generally see more of just a tornado and damaging wind threat in those cases rather than a large hail threat. You want to see weaker low-level shear for large hail production in supercells. And of course, we had very strong low-level shear with this event. But if we say that storms are elevated, let's say this is our surface, where our storms are being fed. Basically, here we'll say just above a kilometer above the surface. that is going to mitigate this entire portion of the hodograph that is below that layer. So in essence, our hodograph is this right here. And then that would allow us to have sort of what we would call very weak low-level shear here, because this is basically where our inflow is coming from here, where our storms are based. So just above that, you can see very weak shear in that layer just above that level. So in essence, that's why storms were tended to be a little bit more hail producing than tornado producing here, especially with northern extent, because our storms appear to be slightly elevated above that surface layer. If they were not elevated, they'd be able to take advantage of this low-level shear, and in fact, would probably be a little bit more likely to produce tornadoes than large hail. And you can see, we saw some evidence of this in some of the storms here. These were the storms that were just at dark here near Yazoo City, Mississippi. This is from my friend Max Olson. He was also chasing. I'll put a link to his YouTube channel in the description below. Definitely check that out. But notice the laminar nature with the storm here. You can see the very sort of laminar looking features there in the low levels with these clouds. And we were talking about this. This is not really the structure you see with your beastly sort of tornadic supercells. If we go back to our photo of the tornado near Thomastown, Louisiana, in the Mississippi Delta there, this is kind of the structure you often see with your beastly sort of tornadic supercells. Very, roiling clouds there in the low levels, lots of lowerings there with that tornado underneath. That is definitely the look of a surface-based storm. Whereas here, you can see that very sort of laminar looking feature here. And this is how you get well-structured storms. You have to have lots of shear in this layer, but you also have to have some convective inhibition coinciding with that layer of strong shear. That's how you get very well-structured storms, and that's exactly what was going on here. Likely a small layer of convective inhibition here that allowed storms to remain elevated, and because we had strong shear there, that's how we got this sort of elevated-looking structure. So there's some pretty strong evidence that storms, at least in the early portion of the event, were somewhat elevated. And that would explain why storms tended to cycle. They would tighten up for a couple scans, and then they would kind of poop out, so to speak. They would sort of gust out. And we can see that on the radar here. If we go forward in time, take a look at these storms here. So for example, these are the Yazoo City storms. You can see that they do try to tighten up there with some low-level rotation, but they quickly sort of fan out and kind of become sort of outflow dominant. You can see the gust front right there along these storms. And that is a pretty telltale sign that there was hail production ongoing with these storms. Because what is hail going to do? Well, hail is really, really cold, right? It's chunks of falling ice. And that cools the air in the downdraft very rapidly, and then that allows for stronger downward acceleration of the particles within that downdraft, and that creates more cold outflow production. So these storms would try to tighten up, but the hail production would allow for strong downdraft and in turn outflow production that would undercut any mesocyclone that would try to develop, especially with northern extent. Wasn't as much of a case with southern extent. Let's take a look at our Hattiesburg Laurel soundings here, again in the vicinity of that Bassfield tornadic storm. Much of the same progression. Notice that the shear profiles overall are a little bit weaker with southern extent down here, a little bit removed from the main low-level jet axis. Still more than adequate for tornadic supercells here. And also notice one thing before we go on here. Notice that the instability overall is a little bit fatter here with southern extent, a little bit more robust instability with our southern mode here as opposed to our, so this is at 21Z at that Hattiesburg Laurel location. I'll go to 21Z at Columbus, Mississippi. Notice our overall instability profile is fairly skinny here with a northward extent. We do have adequate values of mixed layer CAPE there, approaching 1,000 joules per kilogram, but the overall distribution of that CAPE is fairly skinny. And you want to see a little bit fatter CAPE in your more notable tornado outbreak scenarios, because that yields more robust updrafts. When you have skinny CAPE, it doesn't allow the updrafts to really accelerate upward as robustly, as efficiently, and your overall updrafts may tend to be a little bit weaker. Whereas here, with a little bit fatter CAPE, that's not really the case. You have more robust updrafts. So that may be one reason why the southern storms were able to sustain themselves a little bit longer and produce tornadoes, whereas the northern storms just were fighting that little bit of skinny CAPE and elevated nature farther to the north. But back here, notice that the storms, we did not have that elevated nature to the storms here, very strong low-level instability there for those storms to work with, and not as much of hail production in those storms to the south, more of a tornadic mode down there with the southern storms. So I think that is the main issue with these storms. They were just a little bit elevated during the day, and that's what allowed for more of a hail production mode than a tornado production mode with the storms. Now, as we go on into the evening hours, though, the overnight hours, we started to see that low-level inversion sort of dissipate, and we started to see a little bit more of a tornado production occur, especially with southern extent with these storms. So it was just kind of a brief window where that stability sort of worked its way in the low levels there in the late afternoon hours and allowed those storms to remain elevated. Another issue I found was the overall lack of surface flow. And there's been lots of debate whether this is actually an issue here, but just some anecdotal evidence here. Early in the day, we were stationed in Greenwood, Mississippi here, and the winds were fairly strong. You could tell they were 10 to 15 knots out of the south, really pumping that moisture in. You could see the low-level jet pumping northward. But then as we continued into the, as we were chasing, and every time we would get out of the car, the wind would almost be non-existent. Surface flow would be very non-existent. And there's quite a bit of debate here. You can see on the surface map here with eastern extent, just some 5 to 10 knot flow out here. And there's some debate whether this makes a difference or not. I've seen strong tornadoes, especially in the southeast, with very weak surface flow. For example, March 17th, 2021, saw a strong tornado near the town of Morven, Alabama, down here in far southwest Alabama. And the surface flow was non-existent. You could hear the spring peepers clearly, and there was just zero surface flow at all. But we were watching a wedge tornado at fairly close range. So there's some debate whether that makes a difference, and it's kind of a double-edged sword here. If you consider that the surface flow, we'll take this example hodograph here. Let's kind of zoom in on the hodograph here. If you have weaker surface flow, that is going to keep your low-level shear very, very strong. So say we have zero surface flow here. Well, that is going to keep your low-level shear very strong and keep this SRH at a maximum here. Whereas if you have a very strong surface flow, let's say for example here, it's 30 knots out of the south-southeast right here. Well, that overall, I'll draw it in blue here, that overall is going to decrease your low-level shear from a sort of weaker surface wind. So in essence, a weaker surface wind would provide you with stronger low-level shear. The counter to that, and I'm not sure if there's any scientific research to back this up, but of course, we know our supercell. Usually we have a strong rear flank downdraft that is that air from aloft that gets forced downward and spreads out at the surface, usually at the interface of the inflow region, and the RFD is where you get your tornadogenesis to happen in the supercell. Well, if you don't have strong enough low-level flow to balance that outflow from the rear flank downdraft, that rear flank downdraft is going to take over and dominate and try to undercut any circulation that tries to develop in the low levels of a supercell. So it's kind of a double-edged sword there. Low-level flow that's weak, at least in this scenario, would keep those low-level hodographs very, very strong, and that low-level SRH very strong for any supercell that takes advantage of that environment to use. But that might allow the rear flank downdraft to dominate and undercut any mesocyclone that develops in the low levels of any supercell because of that weak inflow, not able to balance that RFD surge. So that's just a hypothesis. Again, I'm not 100% sure if there's peer-reviewed research to suggest that it's done any research on the impact of weak low-level flow on tornadogenesis, but possible hypothesis as to why that was the case. Surface flow was fairly weak, which allowed the RFD to dominate and undercut these mesocyclonic circulations. One last factor that may have been problematic here with getting long-track tornadoes within this event was a little bit of backing that was noted in some of the wind profiles here across the region. This was a proximity sounding from the RAP near the Montgomery, Alabama tornado that happened well overnight that we mentioned earlier in the video. You can see strong low-level shear here, but a pretty significant layer of backing in the mid-levels here. It's pretty much a constant debate whether this Veer-back-veer, it really impacts the supercell evolution and morphology. And generally from experience, I found that the higher up the layer of backing is, excuse me, in the overall atmosphere, the less of an impact it has on the overall supercell and mesocyclone morphology. And if you have that layer of backing kind of closer to that effective inflow layer, then that's when you start to have some issues. But this layer of backing in the mid-levels can eventually start to interrupt the mesocyclone processes and kind of prohibits these tornadoes from being very, very long track. Even though we did have some long track tornadoes, that Fruitdale tornado we talked about earlier on in the video, tracked for 19 miles across Mississippi and Alabama. So decently long track, but eventually this layer of backing may start to interrupt the overall mesocyclone processes. It's a whole different discussion, the overall mathematics of how supercells work, how mesocyclones work. But this backing could have played a role in mitigating the overall long track nature of these tornadoes. And I've talked with people like Rich Thompson from the SPC about this issue. If you can get a discrete storm mode, you're going to get tornadoes in this kind of a profile. Very strong low-level shear, decent instability. You're going to get tornadoes with a discrete storm mode, even if you have this layer of backing aloft. But eventually this backing could start to interrupt the mesocyclone processes and prohibit these tornadoes from being long track. So whether or not this played a huge role remains to be seen, but this may be one factor, especially with the overnight stuff, whereas that might explain why we still got tornadoes from those storms, but they generally tended to be more short-lived relative to what was expected. So that's going to wrap things up here for this video. Once again, this was by far not a bust. Again, we had over 200 severe weather reports, over 60 of those were tornado reports, so by no means was this a bust, but generally, again, underperformed based on what was expected, an outbreak of significant long-track tornadoes that didn't quite materialize, even though we had a number of individual tornadoes within this event. So hopefully this video kind of starts to shed some light on some of the factors that may have impeded the overall intensity of this event from kind of reaching its ceiling. And more research is going to be needed on this event to really determine why that was the case. But hopefully this video kind of starts to shed some light on some of those issues that this event faced and kind of held it back from being a kind of banner day across the Southeast. So with that, thanks for watching. We will see you in the next video.